Hello everyone, thank you very much for joining this live event, lesson 64 from the Java Fundamentals stream, and we continue our discussion today on working with the file system with Java. We'll discuss about the rest of the methods we need to take into consideration from the files class of the java.nio files package, and then we'll compare it with the file class, which is the legacy way of working with files in Java. And you will find pretty interesting today's lesson, because what we're gonna do is that we'll first take the way in which we worked with let's say the whole approach of working with reading from a file in Java and create a very small algorithm, and then we'll refactor it and we will actually use start from the old implementation and try to use the newer implementations, and you will see how the code becomes smaller and you can solve the same problem with a with a shorter code, at least not necessarily very short, but certainly a shorter code. So that's what we are going to do today. And of course, if you're watching the event live, don't forget that you have a live chat there, so you can ask me questions directly in the live chat. And if you don't, you can anytime leave a question in the comment section, and you can find me on Twitter as well, on LinkedIn. We can discuss there if you have other problems. Somewhere during this lesson, as usual, I will share with you again one of the promo codes from Spring Quickly, my second book that is in early access. So stay tuned, because once you get once more of you will join the stream, I will share a new code, and one of you will be able to use it and get the ebook and access to my early access Spring Quickly, the second book I write about Spring. That being said, let me share you my screen, and as I've said, I will continue with an example. So what I'm going to do today, I'm going to implement a very small algorithm that needs me implement reading from a file, and we already did this with BufferedReader in the previous lessons, so I will write it with BufferedReader, considering you know already that, and then I will try to refactor it using some nice methods from the Java.nio Files NIO.file.Files class. So that's what we are going to do, and you will see this way the very big difference between using the old approach, the one that used up to Java 6 or something like that, and the new approach, the one that you should use starting with Java 7. So long time ago, but I can tell you I've still seen a lot of projects using old approaches, just because it seems that developers still tend to use examples that they find in different articles over the internet, which might contain old code and old fashioned way of working with the files. So what I want to do, actually, first of all, I'd like to create a file, a text file, and say I have a verse, I have 4 lines, and I want to count the vowels from this file. So I want to actually parse all the rows and see how many vowels I have in this file. So yeah, let me write first a verse. So say it's text file once again. Okay, and I'm not sure which verse would you like me to write here, but I have only one in mind now, so let me write this one. So you probably know it is Nothing Else Matters from Metallica, but that's not really important. We'll just use these lines to count the vowels, and I will start with the first example here, example 1, where we will implement this using BufferedReader the old-fashioned way, as you know it from my previous lessons. And then I will continue with example 2, where I will take this and refactor it using the files class. So let's see how would we actually count the vowels using the old-fashioned way. Oh my god, I didn't do this for a long time. So first of all, I need to actually get a BufferedReader. So I will say BufferedReader in is new BufferedReader. And to get the BufferedReader, I actually need the file input stream, new file input stream, and then the file input stream is actually like this. No, new input stream reader here, so I need an input stream reader as well here, new input stream reader of file input stream. And then of course we need to specify which is our file is burst, so the one we have directly there. And then what we need to do is make sure that we treat the exceptions, because you know already that we have exceptions when we work with streams. So we need to treat them. And one of the other things you'd like to do as well is making sure that you close the stream. So the easiest way is to use try with resources. Try with resources is there from Java 7. So in case you see a code that's even older than Java 7, you will actually see the streams closed on a finally block, but we won't go too much into detail with this. So this is a verse, I think is the name of the file here. And I have my stream, and you already know how to do this. If you remember, we can declare a line here, and we can actually read everything up to the end of the file. So we say read line, so line by line. If we didn't reach the end of the file, then you can read the line itself, and then the line is a new string, and you want to count the vowels in this string. So what you can do is, I don't know, have a string with the vowels, something like private static string vowels, and yeah, you can just parse the line. So up to the length of the line, each character that we have in the line, I could say line charet I. So if my vowel string contains line charet I, and then I can actually make sure that easier, we have also the capital letters here. So if I is a vowel, then we can do something like count, just do something like, so it requires a char sequence. We can make it a string like this. String is a char sequence, so it should work. So now I will just say, hopefully this will actually work. I didn't test this version for a long time because I now work with the newer code. But yeah, if we have an N here, we can see, we can immediately see if it works or not. See the exception here, and then print out the N. So it's quite a long algorithm, isn't it? We write about 30 lines of code just to count the vowels, and this is something that I don't really like. And what you can see here is that we have a lot of curly braces, parentheses. If we count the indentation, you will see that it's 1, 2, 3, 4 times indented, 5 times if you take into consideration the try catch blocks. So that's actually even worse from the clean coding point of view. And of course you can try to split this into several methods. Maybe you would not have static methods in a real world scenario, but you would have some objects, so you can unit test them. But it's still a long way of writing a code just to count some vowels. 34 it says here. Let's trust this is the number of vowels. I will let you number them to see if indeed you have 34 vowels. I will just trust this is the number of vowels. And yeah, how do we change our implementation to make it shorter? So the first way to change our implementation is to actually use the files class. Let's copy this example and change it. So in the end you will have both implementations and you can compare them. So what happens in example 2 is that instead of having this way, getting the buffered reader this way, we will use one method that you've seen in the previous lesson, but we didn't test it. It was one we said we'll leave for this one, for this lesson. So you might remember that we can say BufferedReader in files, new BufferedReader. So this is one of the nice methods that you can use directly in the files class to get a high level stream. So you have the new BufferedReader and the new BufferedWriter actually methods. These static methods take a path and create you directly the BufferedReader. So by doing so, paths get, and then my name of the file was verse. So I don't change a lot, but you can already see how I managed to change my solution with at least a couple of lines. So you see all these lines here, I took them out completely, and now I got the BufferedReader directly this way, which is only one line of code to get. I don't need to see the file input stream anymore, and I don't need to see the input stream reader anymore. And if I want, I can even use the var word I get here with Java 10 and minimize the syntax even more. So this is the first thing you can do. And of course, if you run it, it basically does the same thing, because I still get a BufferedReader and the algorithm didn't change. But the idea is that I shortened it a little bit with a couple of lines of code. But now let's go to example number 3, and I will show you an even nicer way. I don't copy now because you will see I don't even need to have anymore the while and actually the for here. In example 3, you will see that the files class give you about 4 methods that have as a return type a stream like in stream API, not IO stream. So that stream API that came with Java 8, and that's very powerful. That's a very powerful functionality that was implemented together with what came with the functional approaches in Java 8, if you remember. So we discussed this in one of our previous lessons. So this is a very, very strong approach to work with data. And when you read data from a file, you very often read them line by line if it's a text file, character by character, byte by byte, depending on what you are doing. But the whole idea is that this resembles very much with working with a stream, isn't it? So that's why the files class give you also these very nice util methods that you can use to obtain the data as a stream. And what's so nice about getting the data as a stream is that you can now leverage all the power of Stream API to work with that data that comes from the file. You can filter it, you can map it to something, you can collect it into different ways, group it, and so on and so forth. Just take a look back into a few lessons we've discussed the Stream API, and you've seen that you can do plenty of things with the Stream API. So take a look now, how can we actually change our small algorithm to make use of these new methods in the files class, where you can leverage the power of Stream API to implement to collect the data from a file and implement any kind of an algorithm that work with that specific data. So what should I do here? Well, of course, I still need to get the path, so the path is the same, but instead of using a BufferedReader, I will just say files lines, and this lines method, do you see it? It returns a stream, so that's very important. So I say lines of this file, and then you remember that we still have to treat the exceptions. So we still have an IO exception thrown here, because probably any method of the lines of the files class, because it works with the file system, it throws either a file not found exception, either an IO exception. These two being both checked exceptions, you need to treat them. So we didn't actually escape the try catch. We still have to write the try catch or the throws close, whatever you'd like to do, but we still have to treat the IO exception. But now we don't get the BufferedReader. You actually, at this moment, so this is what happens is that this line 11 here is the stream source. You directly get a stream, and all the values inside this stream are actually the lines, one by one, the lines that have been read from the file. So now all this, taking the buffered reader and taking it line by line, has been replaced by a stream. And not only that it has been replaced by a stream, but you can now actually use the stream as well to see, work and create your algorithm. So you can use the power of all the feature, all the capabilities of the stream to implement your algorithm. So what was our algorithm doing? Actually, it was counting the vowels. Okay, so what I was doing here, I was parsing character by character through all the lines. So I take a line, then I parse every character, I check it is a vowel. If it is a vowel, then I increment n, so that actually counts the vowels. So now, say I will choose the same approach of having a string that declares the vowels, but instead I will use the stream. So what can I do here? I have strings, yeah? If I have strings, but I actually need to go into verifying the characters, then I have to use a flat map. If you remember, flat map helps us. It helps us taking some value and then returning it as a stream of different values. So in my case, I can take the string, the line, this is the line I get from the file, and then what I want to do with this line is change it into a stream of characters, so that after the flat map, instead of having the lines, I have the characters. So I can check the characters directly, and I can say erase stream line split of nothing, and this will basically transform this stream of strings into another stream of strings, but that instead of containing the lines will contain each character of each line as a vowel, as a value, and then we can check which of these is a vowel by simply filtering them out. So you just filter them out and you say that's basically the same condition you used here. If value contains that character, but now the character itself is, so you take the character C and you directly have it here. So you just say something like this is enough. And of course you can, you can actually, in this case, I think you can use the method reference operator if you feel it more comfortable, but I will leave it like this because it's easier for you to see. Now I have lines, I split them into characters, I get characters. I take them out, I leave them, I leave only those that are vowels, and then I simply just do a count. Isn't it? I have the count method already, and then this is the result. So take a look at this, If I system out it, I should get the same result, hopefully. So if I didn't do anything wrong, I should get the same result. Yeah, it's still 34. But now take a look and compare example 1, that's the first one, with example 3, the second one. First of all, we have less lines to implement the same thing. All of them, they enter into one screen. Secondly, you only have one indentation, so you have the try catch, and then you directly have the code providing you the value. You have no loops, no if else's. It's much more easier to read this than reading this one. So when you read this one, first of all, you see this try, you understand these are some resources, you see you have an input stream, maybe you put this on the same line, but it's still difficult to see. Okay, I get a high level input stream from a text file, and then I have a line, I read it up to the end. What do I do here? I take character by character, then I transform the char into a string, so I can check it's contained another string, and then I increment n. If you show someone this code and it's the first time they see the code, I'm definitely sure they will stay a couple of minutes, maybe, or anyway they will need some time to read it and understand what happens. They will understand, of course. It's not a difficult thing. It's just a very small algorithm counting the vowels from a file. But if you provide this code to someone, they will need they will need some time to understand what happens in here. While if you provide this, well, you see file lines from the text. So reading one line 15, I already see that I get the lines from the text, and then I transform them and that's maybe a little bit more difficult to read. But if you know what split method does, we discussed this in one of the first lessons of this stream, you can see that the line is split into characters, and then you filter out the vowels, and then you count them. So you read it like poetry. It's very, very easy to understand what happens. It's much shorter and much easier. So that's why, as I told you in the previous lesson, I find these methods from the files class that allows you to use Stream API for reading from the file. I find them really, really nice. So I would use them for any kind of such implementation. So I would simply use them for any kind of processing of data from the file. Like take a look again at the difference. So this is the old approach. You've seen this up to Java 6, 7, and then compare it with using this one. Yeah, it definitely looks more clear and easy to read. Cool. So that's the first example, and now this is the first method, files lines. I would like to show you 3 more methods from the files class that provide you streams, and I will make one example per each of them, so that you can see what happens and how to use them. You will need them for sure if you get to implement such a functionality using files or the file system. I recommend you use this instead of the old-fashioned way. And of course you need them for your OCP exam. In case you want to attend that OCP exam, you need to know these methods very well. You will find them in your questions for sure, so make sure you learn them and you remember them when going in your exam. Cool. But because there are a few of you already joined, and I see actually many already joined now, it's actually time to share you my next code for the Spring quickly. So you will get as usual a code for a free ebook. It's a 100% discount code. What you should do to obtain that ebook, you should be the first one to use the code by going to the Manning website. This is the link, what I shared you in the live chat is the link to my book directly. You press to buy it, and then when you get to the cart, you just use the code that I will share you, and that will give you a 100% discount. Again, 2 things to take into consideration. One of them is that it will work only for the first of you, so it's not a reusable code. So that means that the first of you who manages to use the code will get the ebook. So don't use the code. Don't try to use the code if you don't need the ebook. If you already have it, or if you don't want to read it, then leave others who may need this book to use the code. And the second thing is, if you already have the book, of course, it's just for the ebook, so it's not for the printed book. So you don't need to use it if you already have it, because you cannot get the ebook twice. I mean, it's the same ebook. You cannot get it twice. So now, if you are prepared, this is the code for today in the chat, and hopefully somebody will use it. And when you read the book, you will leave me comments and suggestions, because I really appreciate those. And secondly, if you like the book, then of course I would really appreciate, for both of my books, if you leave me a nice 5 stars review on both Amazon and Manning. So you can do that if you like the book, and of course leave me comments. Thank you very much. Are there any new methods in Java.nio to learn for the upgrade exam that are not in Java 8? Not from what I know. So no, I would say the methods that you would have for Java 8 are the same ones that you will find in Java 11, just that be careful, because you will encounter them in Java 11 plenty of times using the var word. So this is is not related to of course the Java.nio or Java.io, but you will get the var word used in plenty of syntaxes, so you just have to get used to it. So besides that, I don't think you need to learn other syntaxes, at least not others I found specifically to Java.nio. I would say no, they should be at least most of them the same as the ones for Java 8. Cool. So now we can go to example 4. In example 4, so example 4, I want to discuss the other 3 methods. First of all, we will take the list. So you have lines and you have list, and then you have find and you have walk. So these are the 4 methods that I refer to. So I say lines we discussed about, list, find and walk. So these are the 4 methods returning string. And lines, of course, we already discussed. You see what was the result. Lines takes from a file the lines. It has to be a text file, of course. It takes the lines, and then you can use the lines as elements of the stream. So it acts as a stream API source, and it provides you directly the lines from a text file. List is used to provide you the content of a folder. So the content of a folder, meaning the representation of the folders and files inside that folder as paths. So you get the paths inside a folder that you provide as a path. So let's see what happens if I just say something like path of, and I use dot, which is the parent. I expect I will get the folders here in my project, so that's, but yeah, it's fine. And then we have, of course, to handle the exception, because we have, as I said, IO exception and final found. Expect these for any method of the files class. Expect them for any kind of code that uses the file system. And then, first of all, I just want, it's the for each method of the stream. I just want to print in the console to see where am I at the moment. So I just say system out print line. And you will see the paths inside the parent directory, because it's a relative path. Here is the parent directory from where I have executed, and that's why, as I expected, what you can see here is precisely the project itself, because that's where that's where the command, my IntelliJ executes the command from, so executes the app from. So you see precisely here, you see the folders in your project, so that's expected. Okay, that's what you see here, it's expected. But now remember that you are on a stream, so that's what is basically nice about this feature, is that again it provides you a stream. So you not only can use a terminal operation, you can use any stream terminal operation and any stream API intermediary operation. So if I would like to simply filter out here the, I don't know, files ending with txt, yeah, I can just say filter, and then I write my predicate. So this is the path, ends with, and then I in this case actually I allow only the files ending with txt. I can say only those that are not ending with txt, and then if I run it again, you will see that this line here in the output should disappear. And of course I can map them, I can I can do whatever I want with my filter. So I see here, interesting, it didn't filter them out. That's strange. So my filter for some reason didn't work. Let's see, let me do something else then. I'm not sure if why the end with didn't work there, but I can do it like this as well. So say ends with txt and try it again. Yeah, because it seems that on the path didn't work. So now I only, okay, and I forgot the not in front. So if I add a not in front, then it will be only those who are not ending with txt. Okay, but the whole idea is, yeah, and you can see the result. The whole idea is that you can use the whole power of Stream API now to work with the paths and directories. So that's again a really nice feature. And if you have list, you can actually do a lot of things already, so you don't necessarily need to more than this. But yeah, you have actually two more methods that help you implement even easier some cases, like finding a file by its properties or parsing a specific folder. So let's try to use this as well in other examples. So let's start with walk. see what walk does and then see what find does as well. And that basically concludes what you need to know from the files class, of course taking also into consideration everything we did in the previous lessons. So with this lesson we just end with what you need to know with working with the file system. And of course we then have to take the legacy file class. I won't show you too many things with the file class, but I'd like to show you what's different in the file class versus the new API implementation in Java, and tell you why it's relevant not to use file anymore and use the new approach instead. So yeah, we have instead of list here we can use walk. And when you use walk, you actually have to specify, or you can specify also the depth. So how much in depth of the tree structure of the folder you want to go. You can say from the parent, I'd like to go at a specific maximum depth, and then it will not only list, actually it only gives you the list of the files and folders inside the specific folder, as you've seen in this case inside of the current folder of the project. But if you want to go even deeper, like see what's inside the idea folder, what's inside the out folder, what's inside these folders, then you can actually use walk, and you specify the path, and then you specify a max depth. So how many folders you go into the tree of this folder, you specify as a first parameter. So when you go here, then you'll see many more results, because now it not only goes into the parent folder, it goes into the into the current folder, and then it goes into the first folder, and it goes inside the first folder, and it goes to the second folder, and it goes inside this one, and inside this one as well, and inside this one as well. And that's because I used 10 depth. So this will be the maximum. It goes 1, 2, 3, 4, 5 is smaller than 10. So that's why you see all of this. But if I would have limited this to 3, for example, then instead of seeing all the files, you will see a maximum of 3 folders, 3 nested folders in the hierarchy of this current folder. So I'm running it again, and you see that the result now is much smaller, and you can see that indeed 3 is the maximum depth where the method went with parsing. So walk is an easy way to go into not only a specific folder content, but also the contents of other folders inside the specific folder to a depth that you define. So you can actually use a very, very large here one, but be very careful with using a very, very large. So this limitation here is done for a reason, and the reason is, of course, if you have if you go deeper and you have a big tree, then you of course will need more time for processing that. So you might not want to go too deep if you know you have a very, very deep tree of files and folders. Then you might want to limit your search to a specific depth, and I recommend you just go to where it's needed. Don't try to parse a very big tree, because then it consumes a lot of resources. Of course, imagine it has to go through all of the files and folders, and then if you do something, and you usually do something more than printing it in the console, as I've done here, like you can use, again, it's a stream, so you can use here any stream intermediary operations, then of course it will definitely consume a lot of resources. So that's with walk. And then you have also the possibility to use find. And find is a nice method that allows you to find files by specific properties of theirs. So let's create an example 6 for the find, and the last method from the java.nio file that we present, example 6. And in example 6, instead of using list or walk, I will use the find, which find has also a def, of course. It's like walk, it has the directory in which you search, and then you have the depth in which you are going. So how many folders in the hierarchy are you going to search into? And you have a third parameter here that's a by predicate. If you remember, the by predicate is one of the functional interfaces introduced as well with Java 8, and it has two inputs. That's why it's a by predicate. It has two inputs, but it always has to return a value of true or false. So it always returns a boolean. So it's like a predicate, but instead of getting only one value as an input, it gets two values as an input. So you have to specify this as well, and you can specify it with a lambda expression. So a from attributes, I will say here, and then of course you need to return a true or a false based on the input. So p here is the path, is the current path, the current parsed path, while a is attributes of that path. So what you can do, for example, you can just use the attributes to check different characteristics of the file, like the access time, modified access time, the size. These are often used for different search criteria. Size, for example, in bytes. So you can just say, I want to find only the files that are smaller than some number of bytes. So if you'd like to just find those files that are smaller than a specific number of bytes, then this is the expression you need to use as a by predicate. The path, and then I don't need to use the path, but I need to use the attributes that contains the number of bytes, the size of the file, and then I check it. So how many more lessons are pending in the Java Fundamentals stream? I'm not sure to tell you precisely, but there will be some lessons still, because we have to discuss as well about the Java time package, if I remember correctly, and then we have to discuss JDBC, which is part of the fundamentals as well. And I don't remember to have skipped anything else. So once we finish with this one, we have the Java time, which is pretty easy. We won't go into too many details because it's more of learning APIs, and I don't need to actually explain a lot of things. And then we have the JDBC, which is part of the fundamentals and also requested by the OCP certification. So maybe about 5-6 more lessons. I'm not sure precisely. Maybe more. But we are close to the end of the fundamentals stream anyway. Considering fundamentals, what's important to know for the OCP exam, because many things might be considered fundamentals. My definition of fundamentals is what you need to know for the OCP exam. So that's what it will go through, another 6-7 lessons, maybe more, but that's something around there. Yeah. So cool, you can see now how it's working. I'm not sure if I will get any nice result here. I just added the condition here. It's yeah, I see something. So I see some files that respect this condition, but it was random, so I didn't add this condition with a purpose here. I just wanted to show you how the find method works. Of course, when you use it, you know what you are searching for. So you know that you are searching for files that have some kind of what size you want it to be, or some kind of a specific path, or some kind of other characteristics like the access time and so on and so forth. So any prerequisites for the software architecture stream? Good question. Good question. I have no idea what to tell you. So there are a lot of prerequisites, because I will discuss about not only architectures but access, communication between services like REST, SOAP, message brokers, Kafka. Definitely there are prerequisites, but I'm not now figuring out a list. But at least if you know at least the fundamentals, you can get something out of it. And I would recommend you try watching it, and if you find it too complicated, then ask questions find me on Twitter, for example, or on LinkedIn, ask questions, and I will give you materials like names of articles, books, or other kind of materials you can read to accommodate the different, to familiarize with different things that you might find cumbersome. Okay, cool. So now the last discussion of today's lesson is legacy versus the current approach. So good book for software architectures. Yes, there are a lot of them. So but you don't have any book of software architecture. You have plenty of them, each one leveraging different subjects. So like, for example, the Monolith to Microservices of Sam Neumann. So that's a very good book about monolith and microservices, but it's not the only one. You have the microservices security in action from the Manning. So there are plenty of books. Let's continue this discussion on LinkedIn or Twitter if you want, so that we don't stop the stream now. So it's not one book. That's not one thing I can recommend you. Cool. So the last discussion of today's lesson is actually about legacy approach versus the new approach, and I want to tell you why you shouldn't use the file class anymore. So previously, with up to Java 6, we were using the file class, and to use file, well, an instance of the file class can be used to represent a file or a folder, and you could actually do a lot of operations directly on the file class. So it's only the file class that does everything. So say I want to create a test file here, I will just create the file instance, and then I have create new file, which of course, as any other operation on the file system, throws an IO exception. So looking at this approach, you might find it maybe even easier than using path and files. So because you just have to define the instance of the file, you do that directly with the file class, and then you call directly one of the methods of the file class, which does the operation on the file system. So why is this bad? So it's not that it's very bad. It's actually one of the APIs that has been used for many years in Java. But if you take a look at it, you will observe two important things. One of the most important things is that it doesn't use any abstraction here. So file is directly a class. It's a regular class. You can instantiate it. Yeah, it has the constructors. So it's actually used as a normal class. You can even extend it. It's not final. So you can work with it, and you can directly create instances. So what's wrong with not using abstractions? If you remember, we discussed in the previous lessons the reason why you'd like to use abstractions is because when you deal with paths and the file system, depending on the operating system, you have different approaches, like different ways to define the paths and different ways to work with the paths. So that's why when you use the abstraction by the means of the path interface with the java.nio file path interface, you get, and I've shown you that in one of the previous lessons, you get an instance of a type, and you get that instance specifically to the operating system on which you run your app, and you don't have to take care of that yourself because it's the JVM giving you the correct implementation. And that's because you use the factory method of the paths class, and you say paths get, and you say give me a path representation for the current operating system where the app executes. So that's really important because that's what you don't have with the file. And that's why in many cases I've seen in applications, in legacy code, code that had deal with the operating system itself, and you had an if-else in your application. If it's Windows, then do that. If it's Linux, then do that. And that's something you don't want, as long as we still consider Java as being the language giving you the possibility to create portable applications. So where is the portability in here if you need to take into consideration yourself in the code the operating system on which the app will be executed? See the logic behind it. So you want to avoid at all costs taking into consideration where will your app be executed, because that's the theory in Java, that the applications are portable, that we don't write code specific to an operating system. So with file, because you don't have an abstraction, you have directly the instance. It's not the JVM taking care of that for you, unlike I have shown you that it happens with path and paths. So that's one of the big things. The second thing about file is that itself it doesn't respect one of the most important principles in class design that we call single responsibility. So you might have heard about single responsibility, at least I might have said more things about single responsibility here and there. Is the principle stating that a class or a method or an entity in your app should have only one purpose. So it should have a well-defined purpose and should do only one thing. And file definitely does at least two things. First of all, it can be used to represent the paths. You see that the path representation is the file instance, but it's also the object executing the operation on the file system itself. So we have two responsibilities. So what does the new approach do in regards to that? It separates these responsibilities, and now you have a separate path contract and path implementations that you don't instantiate yourself, you get through the factory method, and these are only taking care about the paths and the operations with the paths. And then we have a separate class that we discussed in the previous lesson and today, files, that implements all the operations that represent actions you do on the file system. So the methods representing operations on the file system, or whatever you want to call them. So this is the second responsibility. So this is how the new approach separates the responsibility, making our code easier to understand and easier to maintain as well. And not only our code, but the JDK itself is easier to maintain, because now it has correctly the responsibility separated. So if you use the file class as the legacy, this is the legacy approach, you can do more or less the same things you've seen me doing with files. If you take a look into the methods, you will see that you can create directories. So for example, has this make dir and make dirs. These are similar and have the same functionality as the create directory and create directories methods we discussed about in the previous lessons from the files class. So it's just called make dir and make dirs, but it's actually the create directory and create directories methods. They have the delete operation. Here it's only one delete method, but it's deleting the file, so it's the delete operation. We still have it here, and a lot of other things like testing the privileges you have, if you have execute, read, write privilege on the file, and so on and so forth. So I can say that anything you can do with file in terms of operations, you can do with files as well. There's only one thing it wasn't included in the file class, if I remember correctly, symbolic links. So if I remember correctly, symbolic links you can't use them with file. You can use them with files with the new approach, but not with the old approach. But besides that, you can actually say they are pretty much the same. But it has these two drawbacks that I have discussed, these two problems, and for these problems it had to be rewritten and separated and remade to respect the principles of class design and create the code, help you first write maintainable code and make the JDK of course itself more maintainable. So that's basically with the today's lesson as well. So I have another question. I've got an off-topic questions. Those of us that got Spring Security book from the MIP stage, is there any difference in the final version? Of course, if you took the very first version where I've released the chapters 1 and 2, then I have constantly, each MIP version, I have constantly added changes for chapters 1 to whatever. So chapters 1 to 20 have been continuously changed. But now if you have the book, you have the final version. So of course, if you take the final version and compare it with the first MIP version, you will find out a lot of differences. But if you got the book at the very beginning, you still have the final version. So you have the really whatever anyone buying the book now has the same thing that you have. Just that buying the MIP, you had also the chance to see the intermediary stages, and you could leave comments and so on and help me write the book. But in the end, everybody has the same final version, including the last version released is the one that you have is the last version that's copy edited and everything is there like I have it right here in the printed book. So what I have here in the printed book, you also have in your ebook. Super. Thank you very much for the questions, folks. Thank you very much for attending this live lesson again. And I hope somebody will make a good use of the Spring Quickly ebook copy. I have one more code. I will share it with you in the next lesson. And hopefully again, in the end, everybody will read the book and you will enjoy the book, and then will also help me with a review. Until then, thank you very much again and have a great time for study.